This is Jody Trana with Chapter 7, Part 1 of Business Finance. This slide is not terribly current, but I still really like it for its visual punch. In investing, in general, we like our investments to double in value every 10 years. This slide shows which investments would have yielded a 100% return over a 10-year period. It's always easier to look back than to look forward. But looking at this can help us to see how differently some investments perform. The blue circles that you see for each company represents the $1,000 initial investment. That blue dot is the exact same size for every single company, even though it may not look like it. The pink circle represents the total value of that $1,000 investment today. The larger the pink circle, the more the investment is worth. Obviously, if the pink fits inside the blue, then you've lost money. There's one company on here that in that 10-year period, that $1,000 is worth less than half that it was 10 years ago. GE. That investment is only worth $490. But look at Netflix. If you had invested $1,000 10 years ago in Netflix, today your value would be $51,966. As I said, this graphic is from a few years ago, but still it shows you the awesome ability to invest and grow your money choosing the right investments. How can we make money above and beyond just getting a job? There's really only two ways. We can either own something that brings us value, or we can loan something. Owning is an equity investment, and loaning is a debt investment. Equity is riskier than lending money in general. The potential returns are higher for equity too. But the payback is more sure and consistent with debt, as there's usually a predetermined interest payment that comes to you. When you purchase stocks, you become an owner, an equity holder in a business. You may or may not receive dividends as your payback, but the real value in owning stock is the shareholder value that should be maximized by the company, and your stock value should grow. When you purchase a bond, you're lending money to a government or a corporation. They promise to pay back the money at a specified future date and give you usually yearly or biannual interest payments for your trouble. Bonds are less risky than stocks in general, but bonds also have lower return potential. There are other investment vehicles. On the left, you'll see different types of savings vehicles to invest your money. The returns on these are generally low, and the risk is also very low. The other investment vehicles that show on the right have higher returns potentially, but they aren't quite as safe. Let's take a look at the rates of return for the U.S. finance market for the last 45 years. In this graph, we have a measurement of the realized return expressed in dollar amount for every $1 earned. You'll notice here that the very bottom line, which is a bright blue, is our inflation rate. We definitely want to have all of our investments returning money over inflation, and you'll notice that the one that barely does that is right above the blue line, is our red line for Treasury bills. Treasury bills are backed by the government and extremely safe, but as you can see, the return is also very small. There's other forms of investments in the financial market that will bring us a higher return. The highest return we see here are international equities. Those are stocks that are in the international market. The next one is at 79.51 are the U.S. equities or the U.S. stock market. You can see that these two amounts have the most volatile ratings, the most volatile returns going up and down, but they also are the very highest. So why don't we just limit ourselves to those financial markets? Because the risk is just too high. Finance managers need to find a balance between the return that is desired and the risk that they can manage. In the last graph, you noticed how the returns varied more when the risk got higher. This chapter is all about measuring risk and return. We're going to be measuring the risk versus the return two different ways primarily. One is by measuring past performance, and one is by anticipating future performance. Past performance will be measured through cash or realized return and the rate of return, and future performance will be analyzed based on the expected rate of return, the variance, and standard deviation. First, let's take a look at an example of measuring past performance through the cash return and rate of return measurements. Let's say we own a stock that's valued today at $50. To determine the cash return, we would take that value of $50 and add any dividend that we may have received. Then, from that, we subtract our original purchase price, our original investment, to determine our cash return. This answer is in dollar format rather than a percentage. The rate of return takes the same information and calculates a percentage of return. We do that by taking the cash return and dividing it by the beginning price. This gives us a relationship between the return and our investment. It's also called return on investment. For this investment, our rate of return is 6.25%. That's based on the $3 cash return on our original investment of $48. Let's look at an example of realized return. Let's say that we invested in one share of Apple stock for $95 and sold it a year later for $115. The company didn't pay any dividends during that period. What is the cash return on this investment? The equation to determine your cash return or your realized return is to take the ending price, add any dividend that you may have received, and subtract the beginning price. Since there weren't any dividends, this calculation is quite simple. $115 as our ending value, subtracting our beginning investment, the price of $95, gives us a cash or realized return of $20. Now let's calculate the rate of return on this same investment. The $20 cash return is divided by our beginning price, so we have return over investment, and 21% is our rate of return. It's always good to be able to quickly analyze your past performance on an investment, but it's probably more helpful to be able to estimate an expected rate of return. The expected rate of return is a weighted average of the possible returns, where the weight of each return is determined by the probability that that weight occurs. I'm covering up some of the columns here in these calculations just to show you that the heart of our calculations are the same as what we just had been determining. So you'll notice here that the blue box says the cash or realized return, and the pink box says the rate of return. The heart of our expected rate of return is based on what we already have realized. Then we're going to determine the likelihood of different rates of return to come up with our total expected rate of return. Now that you can see each column, let's go through them. Column A talks about the state of the economy. Here we have three different states. That is the economy in recession, the economy in moderate growth, and the economy in strong growth. Column B identifies the probability of each one of these states of the economy. We believe that there's a 20% probability that the economy is going to slip into a recession. We believe there's a 30% probability that there will be moderate growth. And we believe there's a 50% probability that there will be strong growth. Column C tells us the end of the year selling price of the stock based on each one of these economic outcomes. You can see that as the economy is stronger, we're determining or estimating the value of our stock to be higher. The next column is column D, which is the beginning price. The beginning price is always the same. What's going to be different is the outcome. So we have $10,000 for each one of the different possibilities here. The next column, column E, is to determine the cash or realized rate of return, which is just our end of the year selling price minus the beginning price of the stock. We'll also calculate a rate of return, which is the return over investment. And then we will determine the probability of each one of these rates of return by taking the probability times the rate of return. So for the first line for recession, we take 20% from column B, that's our probability that the recession will happen, multiplied times a negative return of 10% gives us a probability of a 2% negative return overall. We do each one of these different economic outcomes to come up with the total probability, which is 12.6. We are expecting 12.6% return on investment based on these potential economic outcomes. Let's see how this table compares to the math equation that we've been using. You'll see that the rate of returns are included in the math equation for every one of the probabilities. You'll also see that the probability percentages add up to 100%, and they are also used in our equation. In the equation, the first two numbers come from our recession probability. We're expecting a negative 10% rate of return, and the probability of that happening is 0.2. The second set comes from our moderate growth economic expectation. That rate of return is 12%, and we expect a 30% chance of that to happen. And finally, the third one comes with a rate of return of 22% and a 0.5 or 50% chance of a strong growth economy. These probabilities add up to 12.6% overall. Which of these stocks is a better investment? When all we have is the expected rate of return, it can be very difficult to make that decision. Knowing the expected return is very valuable, but we also need to understand what the risk is. Standard deviation is a measurement of potential risk. Here you can see that stock B has a much higher standard deviation than stock A. Therefore, its risk is quite a bit higher. Now that we have this information, it looks like stock A is the better deal. I'm going to show you a few graphs that show risk in a graphical way, as they just may resonate with you better. The broad bell that curves in these two graphs, they represent the range of returns that are possible. There's three bell curves here, a purple one, a blue one, and a red one. The more broad the curve, like the blue one, the higher the risk, and the higher the standard deviation. The purple graph shows an investment that could return anywhere from a negative 20% to a positive 50%, with the highest probability that it will land in the 15% range. Take a look at the risk associated with a treasury bill. We can't even see how high this goes, but it would stop near 100%. There is near a 100% probability that you will get the 5% or whatever rate it is for the treasury bill. There's really no bell curve on treasury bills because there's no risk. The standard deviation for treasury bills in this case is 0. You'll also see the graph for the red investment in the top right. That is also a low risk investment because there is not a great deal of risk stretch like there is in the blue bell curve. I'm going to show you two graphs. The first one is a splatter graph of the Standard & Poor's 500 returns from 1928 to 2017. The red line shows the average. So you can see how wide the fluctuations are from year to year. It's also interesting to note how few annual returns are anywhere near the long-term average. These inconsistencies are one of the reasons the stock market befuddles so many people. Here you can see the same type of graph, but this time we're plotting bond returns instead of stock returns. You can see that there is less risk in bonds because most of the bonds are returning somewhere near the average return rate. There are at least two ways of measuring risk. We're going to be concentrating on these two in our course. The first is variance, and the second is standard deviation.